All right, so here's our chapter 3 notes. We talked about the mean, which is our average. Mean for population is the Greek letter mu. Mean for a sample is our x bar. Median is the middle number, and mode is the number that occurs most often. So for qualitative data, we use mode. For outliers, it affects the mean. Ranked data, we find the median, and central tendency is all of them. So mean, median, and mode. So we have histograms. Histograms are these little charts that you see down here that we take the data and we put a bar chart. Then we find the middles and we connect the dots. So they could be symmetrical, where all three measures are identical and in the center, or they could be skewed. So they could be leaning one way to the left, leaning one way to the right. They could be left skewed and right skewed, where measures alphabetical from the tail to hip. Outliers can pull our data or skew our data. So to see this better, for symmetric, notice in the middle is our mean, median, and mode. For symmetric histograms and frequency distributions with one peak in the middle, the values of the mean, median, and mode are exactly the same, and they lie in the center. So everything is nice and symmetric. We have a nice bell-shaped curve. Everything's good. If it's skewed to the right, so meaning our tail is to the right. Our tail is to the right. For a histogram and frequency distribution curve skewed to the right, the value of the mean is the largest. The value of the mode is the smallest, and the median's between the two. Notice that the mode is always at the peak, so it occurs most often when it's our frequency. The value of the mean is the largest in this case because it is sensitive to the outliers. Whenever we have a really high number, really low number, it'll pull the mean to the right. So keep going, and we have our left skewed. Here's where we have the tail to the left and the peak is to the right. If a histogram and frequency distribution curve are skewed to the left, the value of the mean is the smallest. Then it comes the median, and the mode, remember, is always at the peak with the largest. In this case, the outliers in the left tail pull the mean to the left. So that is how it's skewed. It's kind of just going through definitions, and then we'll get into the nitty-gritty problems. So 3.2, measures of dispersion. We have what's called our range, which is where we're going to take the largest value minus the smallest value. We have our standard deviation, which is a measure of how spread out the numbers are. It's always positive, by the way, because number of how far it's spread is a distance, so it's always positive. And it's the square root of our variance. We're going to talk about the variance in a second. So for standard deviation, we have some symbols, so that way we don't have to write standard deviation every time. For a population, it looks like this. And it's what's called sigma. Lowercase sigma, by the way. Remember, uppercase sigma is the sum. It's kind of like a 0 with a hat. And then for sample, this one's easier, just an S. Again, those Greek letters coming into play. So we said that the standard deviation is the square root of the variance. So the variance is the average of the squared differences from the mean. Because we're squaring it, again, it's always going to be positive. Our symbols for our variance, population is just taking that sigma, and then it's squaring it. For sample, we have our S, and then we're squaring it. Then we have these crazy formulas. So for variance, for population, we have sigma squared is the sum of our x squared minus the sum of x squared all over n, all over n. Notice for population standard deviation, it's the square root of the variance. So same exact formula, just a square root. Sample variance is over here. Same thing, but we have lowercase n, and then we have n minus 1. This is our sample size. For sample standard deviation, it is just our sample variance, taking the square root. We'll use those in just a second before we get to actual problems. Last two definitions for this page, we have what's called a parameter. It is a numerical measure for a population. Population is our main word here. because for statistic is a sample measure, a summary measure for the sample. So population is for parameter, sample is for statistics. Thankfully, they were nice whenever they made this. And P goes together, S and S go together. So that's cool. So we have one more little piece of definitions and formulas on the next page, and then we'll get into actually doing stuff with this. And it won't look like such Chinese. Questions, comments, concerns so far? Just kind of going over the basics before we get into the nitty-gritty. All right, so next page. 3.3, mean, variance, and standard deviation, this time of group data. M is the midpoint of the class. F is the frequency of the class. We have some formulas for group population mean, group sample mean, group population variance, group sample variance, grouped population standard deviation, grouped sample standard deviation. So let's get into using this stuff. By the way, on our formula sheet for Chapter 3, we have all of those formulas here for us, so don't freak out. Also, our calculator is going to do most of this for us anyways. So it's not as scary as it looks like, because this looks kind of scary, I'm not going to lie. So not as bad, I promise. So for example, for the ungrouped data set given here, find the following. So first it asks us to find n. So we have all these numbers. We have 19, 14, 11, 11, 18, 20, 10, 19, 11, 18, 20, 18, 10, 11, and 15. So n, how many numbers are there in this group? 15. Good, thanks. So if you count it up, there are 15 items here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is the number of values. Finding the mean. Remember, to find the mean, we're going to add everything up and then divide by however many numbers there are. So we can write this symbolically as adding everything up, the sum of x, all over the number of things there are, so all over n. So if we add this up, 19 plus 14 plus 11, 11, 18, 20, 10, 19, 11, 18, 20, 18, 10, plus 11, plus 15. Added it all up gives us 225. Divided by 15. We said there was 15 data points. So divided by 15 will give us 15 for that mean. Remember, median is our middle number. We also remember for median, our numbers must be ranked. So we have to put them in order from least to greatest. So, I already did that. Oops. 10, 10. 1, 2, 3, 4 11s. 14, 15. 1, 2, 3 18s. 19, 19, and 20, 20. So we rank them in order from least to greatest. So now to cross off from the beginning to the end and cross off to find the middle. So crossing it off, the first and the last. First, last, first, last. Crossing them off as we go, first and last, until we get to the middle. Boom, which is 15. Notice I cross off 7 numbers here, 7 numbers here. We were trying to find the middle number. What happens if you find the middle number and there's 2?
2.
Good. Add them, divide by 2. We're going to find the mean of the two middle ones. Find the average of the two middle ones. Mode is the one that occurs the most often. What is it? Yeah. 11. Good. Thank you. The one that occurs most often, which is number 11. All right, so that's our example A. Moving on to example B. Before we do that, questions, comments, concerns for me, please. All right, so moving on. So for the sample below, find the range, the variance, the standard deviation for the distance jumped in feet by 9 long jumpers. So before even looking at the thing, how many did it tell us that they looked at? 9. So our n value is 9. Our range, remember, is the largest number minus the smallest. Which one's the largest number? 21 minus? Oops. Yeah, 21 minus 10. Good, thank you. 21 minus 10, which will give us 11. So now we're going to try to find the variance and the standard deviation. We're going to use this table below to help us do that. We're going to do it the long way, and then I'll show you a better way. All right, so writing all of our data points out, our x values. So we have 21, 15, 12, 18, 10, 10, 14, 17, and 11. Yes, sir.
Sorry if you just answered this, but I was writing a note.
It's okay, go for it.
You said mode
Bless
would
you.
be the most often.
Right?
And what if there were an equal amount?
Yeah, we could have either no mode or we could have multiple numbers for our mode. Good point.
Okay.
Does that answer your question? Yeah, that's really good. So if there's like, say they all only occur one time, so no number occurs most often, so there would be no mode. Or say that we had 4 numbers that occurred 4 times, that was the most amount. They
For
all
median,
4 of
there
them.
has to be one number.
Right, so the median and the mean have to be one number. But the mode could be multiple or it could be none. Yeah, great point. Thank you for bringing that up because I did forget to mention that, so thank you. All right, so going back to variance and standard deviation. So this chart asks us to find now x squared. So I want to take our x column, we want to square it. So going down our list, 21 squared, 15 squared, 12 squared, 18 squared. That was an 18 squared. Before I get too far, let me start writing down. So going down our list, so 21 squared is 441, 15 squared is 225, 12 squared is 144, 18 squared is 324, 10 squared is 100, 10 squared is 100, 14 squared is 196, 17 squared is 289, and 11 squared is 121. All right, so if you look on the next page before I flip over, it asks us to find the sum of the x column and the sum of x squared. So let's do that while we're here. So the sum of our x column, let's add up all this x column. So 21 plus 15 plus 12 plus 18 plus 10 plus 10 plus 14 plus 17 plus 11. Whew. Adding it all up will give us 128. And then adding up this x squared column, so 441 plus 225 plus 144 plus 324 plus 100 plus 100 plus 196 plus 289 plus 121 will give us 1940. So we're going to use these things in our formulas on the next page. Before we go to the next page, questions, comments, concerns for me? Alrighty, next page. the sum of x, we said was 128. The sum of x squared was 1940. The next one says the sum of x in parentheses and then square it. So what was the sum of x? 128. So we take that number inside our parentheses and then square it. We should get 16,384. By the way, one more little piece that we need to know, so that way all of our data is at one spot. Our n was 9. That's everything we need right there. So it asks us to find our sample variance. It was this big, crazy, ugly looking formula. So it was s squared equals the sum of x squared minus the sum of x in parentheses squared over n all over n minus 1. Looks scary, but we already have all the information to plug into this. I just copied that same formula from the formula sheet or from the definition beforehand. So that way, the sum of x squared we said was 1940 minus, in parentheses, we said the sum of x in parentheses squared was 16,384 all over n, which was 9, all over n, which was 9, minus 1. So now, still doesn't look that pretty, but it doesn't look as scary. So I can plug this into my calculator exactly like we see it. The hardest thing about plugging this into the calculator is there's so much stuff going on that we need to make sure to tell the calculator, okay, what goes on the top of the fractions, what goes on the bottom. So it's super important to have parentheses. So I need a parenthesis around the numerator of my fraction. Notice I already have parentheses around this fraction. And I need a set of parentheses around the denominator. So now, or if you just want to put 8 in the bottom, that's fine too. So now whenever I plug into my calculator, it's exactly how I see it. So I have a parenthesis, 1940 minus another parenthesis, 1634 divided by 9. Closing off, I have two parentheses here. Divided by, in parentheses, 9 minus 1, closing that parenthesis. So if you see, whenever you write it out, it's exactly how you write it. Parentheses around their fractions to separate our fractions. Press enter. Yeah, what did I forget? Oh, thank you. Gotcha. 1384. All right, so just to show you what I did was, see, I forgot the 8, and I was, remember, efficient, not lazy. So instead of writing the whole thing over and pressing clear, you can press second entry, so second enter. So see down here above enter button says entry. I can do second enter, and it pulled me up what I previously wrote. I used my arrows to scroll over to what I missed, and I did second delete, which says insert, and I inserted an 8. Yeah. So instead of having to rewrite that whole thing, I can just go back, put in whatever I entered, and then insert the missing number. So now my answer was 14.94. And Wiley Plus, and on the test, it'll tell you how to round. Questions, comments, concerns for me, please, about sample variance. About sample variance. So now taking the sample standard deviation, remember that's just S. The standard deviation is the square root. S is the square root of S squared. I know what S squared is. I know what the sample variance is. So it'll be the square root of 14.94. So remember, statistics is really, you have to be really exact. So a lot of times what I'll do, instead of rounding, I have this 14,94444 going on forever, which is more exact, already into my calculator. So now I want to find the square root of that number. So the square root is right here above x squared. It's in blue. So I need to hit my second button first. Will give me all my blue keys. So second, x squared will give me my square root. I want the square root of that answer. So if you see above the negative sign, it says answer in blue. So I need to hit second and then the negative symbol. So taking the square root of my answer. Press enter, and that will give us a more exact number, which will be 3.87. So we're going to do the same concept for the next example. Before going there, how can I help you? Next page, or sorry, next example. For group data from a population. So last time we looked at a sample, now looking at a whole population. Find the mean, the variance, and the standard deviation for the population surveyed below. Commuting time between 0 and less than 10 minutes, we have 6 of them. Between 10 and less than 20, we have 10 of them. 20 to 30 is 3, 30 to 40 is 9, 40 to 50 is 2. So we have to find the midpoint. M is the midpoint. So to find the midpoint, remember we took the two lower limits and we added them and found the middle. So 0 plus 10 divided by 2 gave us 5. And then we have 10 plus 20 divided by 2 will give us 15. 20 plus 30 divided by 2 will give us 25. $30 plus 40 divided by 2 will give us 35. And 40 plus 50 divided by 2.
Can we just write the middle?
Yeah, that's okay. I was just showing you how I got it for note's sake. Yeah, any of this stuff that you can just see, that's totally okay. I'm going to show you how to do it in the calculator in a minute too. So now taking M times F, taking our midpoint and multiplying by our frequency. So 6 times 5 will give us 30. 10 times 15 will give us 150. 3 times 25 will give us 75. 9 times 35 will give us 315. And 2 times 45 will give us 90. And our last column says M squared times F. So taking our midpoint, squaring it, and multiplying by our frequency. So basically our midpoint, which is 5, squaring it, times our frequency, which is 6. So in our calculator, 5 squared times 6 will give us 150. Going down our list, 15 squared times 10 will give us 2250. 25 squared times 3, 1875. 35 squared times 9. Putting that into our calculator, we'll get 11,025. So 11025. And last but not least, 45 squared times 2 will give us 4050. 4,050. All right, so here are the columns that we filled out. Last thing we have to do for the chart before getting into the nitty-gritty is find the sums of all of them. So to find n, we need to add up to see how many people that they surveyed. We need to add up our frequencies. So 6 plus 10 plus 3 plus 9 plus 2. Will give us 30. Adding up m times f, so adding up this column, 30 plus 150 plus 75 plus 315 plus 90. Adding them all together was 660. And adding up this last column, that was m squared times f. So 150 plus 225, so on and so forth, will give us 19,350. 19,350. So now we have everything that we need. Now that we have everything that we need, we can find our mean, variation, and standard deviation. This is not variation, this is variance. Sorry. Spell check must have got me.
The n you added all of them?
Yep, I added 6 plus 10 plus 3 plus 9 plus 2.
Where'd the n come from?
The n is like how many people are in the population. It's the same thing as the sum of f.
I was going to say, why don't they have the sum?
Yeah, it's just saying like there's 30 people in the group. So we usually call n. Our formula uses the letters n. Uses the letter n.
So,
So-
up at the top, the n was how many numbers it was?
Yeah. Are you asking me or are you telling me?
On the other question above it, it said n was 9, so that's just how many numbers.
Right, bingo, yep. This is lowercase n, so it's for the sample. This is uppercase n because it's set of population. So sample is just a smaller group of the whole population. Does that answer your question?
Yeah, I was just wondering why it was 8.
Yeah.
And not have
Just
the
to
sum
make-
of that.
yeah. Because we use n, I think, so much. But yeah, that would make more sense. All right, so for mean, remember mean is of a population. So we're going to use the letter mu, which is the sum of m times f all over n. So it's saying commuting time of about 5 occurred 6 times, so that means it gives us 30 of them. So that's why we're using this m times f column. So we have 660 divided by 30, just plugging in our sum of m times f, which is 660, divided by our n, which is 30. And our calculators will give us 22. So for our variance, remember it's a population, so we have like this sigma. So sigma squared equals the sum of m squared times f, which we have, minus the sum of m times f, which we have, taking that value and squaring it, divided by n, which we have, all over n. So it's exact same as that previous one we just did. This is the formula that will be on the formula sheet on the test. Plugging in these values. So sum of m squared times f, we said was 19,350, minus the sum of m times f, which we said was 660, all over n, which we said was 30, this had parentheses around it too, all over n, which was 30. Just like the previous example, I need to put parentheses into my calculator to show, okay, what's on top of my fraction, what's on the bottom. So I put parentheses around the numerator and parentheses around the denominator, the tops and the bottoms of the fraction. When in doubt, put parentheses there. They won't hurt you, but it'll hurt you if it's not there. So plugging this into my calculator exactly like I see it. So I have a parenthesis, 19,350 minus a parenthesis, another parenthesis, 660, parenthesis, divided by 30.
Is 660 supposed to be squared?
Yes, it is. Thank you. Nice. So 660 squared. Thank you for catching that. Divided by 30. Then I had two parentheses, shutting that off.
Bless you.
Bless you. Divided by, in parentheses, 30. Some of you are probably saying, you don't need a parenthesis around 30, you don't need a parenthesis around 660. That's fine. I just like putting parentheses just for the like habitual, like always putting parentheses. Yes, ma'am.
So on the 104, they did 9 minus 1, but on this one you need to subtract for n, or n.
Right. So up here, this was the sample. So whenever it's a sample, it's n minus 1 is our formula. Down here is a population. So population, it's just n, just going back to the formula. So good observation. But yeah, very tricky. So thank you for pointing that out. So equals 161. So that's our variance. That's the hard part, because now our standard deviation is just the square root of that variance. So our standard deviation is the square root of the variance. So the square root of 161. Putting that into our calculator, second square root of 161. And we get that decimal, we're going to say it's 12.69. 12.6, we're going to round that next number, which is an 8. Looking next door from that 8 is another 8. Remember, 5 or higher, it rounds up. Anything less than 5, it's going to stay the same. So that's why that 8 rounded up to a 9. So we're getting into the nitty-gritty. Questions, comments, concerns from me thus far? I'm going to show you something that you're going to like. Before I do that, I want to make sure you're good on this part. Because this is a lot, right? There's a lot. I don't like doing a lot. Let's show you why. Are you ready? All right, so I can put, these are lists, right? I can put this list into my calculator. So if you go to stat, right here it says stat, below delete, and I want to edit my list. So I want to press edit. I already have stuff in here because I was already doing statistics. If you don't, that's okay. I already have stuff in here. I want to clear it out. So I want to press delete, and I want to delete all these bad boys out. Same thing for both lists. Delete them out. So I have two columns. We dealt with two things. I dealt with the midpoint, and I dealt with the frequency. So for the midpoint, I'm going to put it in L1. I want to make sure to label it on my paper as L1 because it gets super confusing on which one's which. So L1, and I'm going to put my frequency in as L2. You can do either one as long as you label it. It's just kind of like what usually happens. We usually put the midpoint in L1 and the frequency in L2. So putting those numbers in, L1 is my midpoint. So 5, enter. 15, enter. 25, enter. 35, enter. 45, enter. Moving over to list 2, I'm going to put my frequencies. So 6, enter. 10, 3, 9, and 2. So I entered in my data. Questions so far? Because I know this is what we want to see. Questions so far? Yes, ma'am.
How did you get to that?
So go to our stat button. And then our first thing says edit. So press enter. Yeah, and you're going to see, by the way, because I see a lot of us have a lot of different types of calculators. So if you have an older calculator, if you have an 83, it's okay. It's just not, it's not as pretty, and you're going to have to do a little bit extra. So remind me, because sometimes I forget, if you have an 84, you're good. They should all look the same. But this just does a little bit more for us. So just don't let me, if I move over something, just ask me. All right, are we good with putting in L1 and L2? Yeah, are we okay? All right, so going back to stat, I want to calculate. So going to calculate. I looked at one thing. I only looked at commuting time. So I only have one variable. So one variable statistic. So press enter. So it asked me my list, which is my midpoint. That is L1. My frequency was L2. So I want to put in L2. So if you need to put in L1 or if you need to put in L2, it's above number 2 in blue. So I need to hit my second blue button and then number 2, and it'll give me list 2. So my actual midpoints, my list was L1, my frequency was L2. Going down, pressing calculate for pressing enter. Look at this nice information they give us. It gives us X bar, which is our mean, which is 22. It gives us our sum of X, which was 660. We had to do the M times F and all that good stuff. It gives us sum of X squared, which is 1935. It gives us our standard deviation. It gives us our variance. We are good to go. It gives us a bunch of stuff. So you see 1969 down here because it's a population. Taking that number and squaring it would give us our variance. So this is super cool. Gives us a minimum. It gives us our median. It gives us our maximum, and we'll talk about some of the other stuff. So this is super cool. I don't even have to worry about these crazy, ugly formulas. My calculator does these crazy, ugly formulas for us. So we're not going to do those again. Yes. Question. So we're going to do another example using this formula. Before we do that, pausing for a second.